Welcome to today's Explainer, where we are diving deep into Cambridge Mathematics exam mastery. I'm your host, the strategist, and today we are tackling one of the most notoriously mishandled topics across the 0580, 0606, 4024, 4037, and 4040 syllabuses, sketching curves. If you've ever stared at a blank page during a high-stakes math exam, heart racing because you were asked to draw a complex curve from a chaotic-looking equation, you are exactly where you need to be. Think of structural frameworks in mathematics as magic spells. If you cast the right spell, you unlock maximum marks. But cast the wrong one, disaster. Let's look at two typical students facing a standard curve sketching question. First, we have Alex. Alex is an overloader. He sees an equation, panics, and starts calculating 20 different coordinates to plot, completely ignoring the command word, wasting 10 precious minutes, and completely losing the overall analytical picture. On the other extreme, we have Sam. Sam is a rusher. Sam misses the command word requirements entirely, draws a messy, completely unscaled scribble, misses the invisible boundaries, and bleeds easy marks. Today, we are going to fix both of these approaches. We're going to hook into a fantastic structural concept. Every single complex math graph you encounter at this level actually belongs to a predictable, recognizable family tree of shapes. Master the family, master the exam.
Here is our exact blueprint for today. We'll decode the core rules of sketching, master linear and quadratic graphs, conquer the cubic double bend, analyze reciprocals and exponentials, and finally, lock in the ultimate graph family system. Let's get straight to work.
Section 1. Core Rules of Sketching.
To start, we need to completely decode the Cambridge command word sketch. When an examiner uses the word sketch, they are explicitly telling you not to do what Alex does. They do not want a perfectly plotted set of 20 coordinates on graph paper. They are testing your analytical understanding of the function's structural framework. To secure top marks, top students apply a variation of the Peel framework, point, evidence, explanation, link, directly to their math answers. In sketching, your point is identifying the correct shape. Your evidence is calculating the specific axis intercepts. Your explanation is the smooth, unfeathered curve you draw, and your link is tying it all together with asymptotes or turning points. Step 1 of this framework is your universal DNA. Substitute x equals 0 to find the y-axis intercepts. Step 2 is substitute y equals 0 to find the x-axis intercept. It is that simple. Showing this working out is your evidence, and it instantly secures you method marks, even if your final drawing is slightly off. Now, before we continue, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
Now, let's address a major pitfall where Sam always loses marks, the asymptote. This is a critical vocabulary word for your exam. An asymptote is a line that the curve gets closer and closer to, extending out to infinity, but it absolutely never meets or crosses it. I want you to think of an asymptote as an invisible, highly charged electric fence. When the examiner looks at your sketch, they are specifically checking if your line hooks away from this invisible fence, or if it carelessly crashes through it. If you cross it, you instantly lose the accuracy mark for that section of the curve. Keep this concept front of mind. It is the ultimate differentiator between an A grade and a C grade on advanced functions. Section 2. Linear and quadratic graphs. Let's see the transformation in action. We are going to start with the absolute foundation of our graph family tree, the linear graph. Now, I know what you're thinking, straight lines are easy, but this is exactly where overconfident students drop marks. Look at the equation 2x plus 3y equals 12. Alex would try to rearrange this into y equals mx plus c, risking algebra mistakes under pressure. Don't do that. Use our structural spell. Set x to 0. Instantly, 3y equals 12, so y is 4. There's your first coordinate at 0, 4. Now, set y to 0. Instantly, 2x equals 12, so x is 6. There's your second coordinate at 6, 0. You write those numbers clearly on the axes. You grab a ruler and you draw a single, confident line through them. The examiner sees the intercepts clearly labeled, sees the straight line, and boom, full marks awarded in under 30 seconds. You've just saved crucial time for the harder questions at the back of the paper. Moving up a tier in our framework, we hit quadratic graphs. These are the classic y equals ax squared plus bx plus c equations. The Cambridge examiners have a very specific checklist for these. First, they check the overall shape. Is it a perfectly symmetrical U shape because A is positive? Or is it a symmetrical N shape because A is negative? Sam frequently draws these looking like wonky V's or squashed circles. You must practice drawing a smooth, sweeping parabola. The second thing the examiner looks for, and this is where the real marks are hidden, is the exact placement of the turning point along that perfect line of symmetry. So, how do we transform a sloppy sketch into a guaranteed full-mark answer? You explicitly calculate the turning point. This is your mathematics success blueprint for quadratics. You have two incredibly powerful strategies here. Strategy 1, because of that flawless symmetry, the x-coordinate of your turning point is always exactly halfway between your two x-intercepts. Add the x-intercepts together and divide by 2. Strategy 2, which Cambridge absolutely loves to test, use the completed square form. If you rearrange the equation into y equals the quantity of x minus a, all squared plus b, you don't even have to calculate anything. The coordinates of the turning point are simply ab. It is literally hiding in plain sight. If you label that turning point coordinate clearly on your sketch, the examiner has no choice but to give you the maximum available marks.
Section 3, the cubic double bend. Prepare for the interactive workshop. We are entering the high-value mark territory now with the cubic graph family. I'm going to put 60 seconds on the clock in our minds for this first challenge. I want you to mentally scan the data presented by a baseline cubic function, y equals ax cubed. What is the core trend here? Think about it. Unlike a quadratic that turns back on itself, a positive cubic function swoops up from the bottom left quadrant, hits the origin where it momentarily flattens out, and then continues its journey swooping up into the top right quadrant. It is a continuous, flowing shape. Now apply your exam strategy. What happens if the equation is y equals negative ax cubed? Instantly, you should visualize that exact shape reflecting across the y-axis, starting top left and ending bottom right. Recognizing this baseline shape is your anchor.
But Cambridge examiners love to push you further. They rarely just give you the baseline. They will give you a factorized cubic, something like y equals x times x plus 6 times x minus 1. This is where the signature cubic double bend comes to life, because the curve now has to pass through 0, -6, and +1 on the x-axis. It has to physically snake up and down to hit all three targets. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at Ace the Exams IGCSE, to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to at Ace the Exams IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Section 4, Reciprocals and Exponentials. Time for challenge number 2.
Let's look at the families that truly terrify unprepared students, the reciprocals. The equation has x trapped in the denominator, like y equals -2 divided by x. Now here's your find the flaw challenge. Imagine Sam writes on his exam paper, the reciprocal curve crosses the y-axis at 0. Identify the fatal flaw in that sentence. Got it? The flaw is that you literally cannot divide by 0 in mathematics. It breaks the universe. Therefore, the curve can never, ever cross the y-axis where x is 0. That physical impossibility creates our vertical asymptote. We also get a horizontal asymptote along the x-axis because as x gets infinitely huge, the fraction gets infinitely tiny, but never quite reaches 0. So our reciprocal graph shatters into two disconnected, sweeping curves trapped in the quadrants created by these asymptotes. If you draw them connecting, you lose all marks.
Now for challenge 3, speed visualizing. You have 30 seconds. The equation is y equals 2 to the power of x minus 8. This is the exponential family. Unlike the shattered reciprocal, this is a single continuous curve of massive, rapid growth. Apply your PEL framework immediately. What's your evidence? Find the y-intercept. Set x to 0. 2 to the power of 0 is 1. 1 minus 8 is -7. Your curve crosses the y-axis at -7. Now, where is the invisible electric fence? 2 to the power of x can never be 0, so the lowest the y value can possibly get is hovering just above -8. That is your single horizontal asymptote. You draw a dotted line at y equals -8, mark your intercept at -7, and draw a smooth curve rocketing upwards to the right. Let's distill this into a brutally effective cheat sheet rule that you can memorize right now. When you decode the exam question, look at where the x is. If x is in the denominator, you are dealing with a reciprocal graph, which means you must draw and respect two asymptotes, one vertical, one horizontal. But if x is the power itself, the exponent, you are dealing with an exponential graph, which means you only have one horizontal asymptote acting as the absolute floor or ceiling for that explosive growth. Memorize this distinction. It saves you from the classic exam room panic of confusing the two families. Section 5. Master the graph families. Let's build your final system. We are now going to compile your ultimate mathematics answering system. These are the 3 non-negotiable rules that guarantee top marks when sketching curves. Rule 1 is all about command word decoding. If the paper says sketch, do not act like Alex, do not draw a grid, do not scale your axes with tiny, agonizingly precise tick marks of 1, 2, 3, 4. It is a massive waste of time, and it completely, entirely misses the point of the question. The examiner is grading your knowledge of the correct general shape of the function's family. You draw a clean vertical line, a clean horizontal line, and you smoothly draw the family shape. Fast, efficient, and analytically superior.
Rule 2 is the flawless application of our modified Peel framework. You must anchor your abstract shape in reality. An unanchored shape gets partial marks at best. How do you anchor it? By finding the evidence. You always, without fail, substitute x equals 0 to find the y-intercept, and substitute y equals 0 to find the x-intercept. Once you calculate those numbers, you must physically write the actual numerical coordinates right there on the axis line where your sketch crosses it. This is you explicitly telling the examiner, I know exactly where this function lives in mathematical space. It is undeniable proof of your competence.
Rule 3 ties into our time management matrix. The most precious resource in a Cambridge mathematics exam is not your calculator, it is your time. You need to bank time on these sketching questions so you can spend it on the brutal vector or calculus questions at the back of the paper. To do that, you must memorize the visual shapes of these 5 families right now. A linear equation is a ruled straight line. A quadratic is a symmetrical U or N shape. A cubic is a flowing snake or double bend. A reciprocal is a disconnected curve trapped by crosshairs. An exponential is a rapidly rocketing ski slope. When you look at an equation, you shouldn't have to think. The shape should instantly manifest in your mind's eye. I am leaving you with this final test of your new framework. Look at this equation. Y equals 3 to the power of x minus 5. Right now, ask yourself, which family is this? How many asymptotes does it have? Where exactly is the invisible boundary line? And where does it cross the y-axis? Visualize the exact path your pencil would take. Students who implement these specific mathematics strategies see an average improvement of 2 full grade boundaries. But that only happens if they practice consistently with our weekly strategy sessions. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every single comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here.